So today we're going to be talking about solving systems that involve quadratic equations. We can use the methods similar to the ones that we've used to solve systems of linear equations. So what methods were used to solve systems of linear equations? Just take a second to try and think of what three methods we talked about. Okay, so the three methods that we used were graphing, substitution, and then also elimination. So how many solutions can a system have that consists of a linear and a quadratic equation? Let's look at a few examples on the next page to find out. Okay, in our first example in letter A, we want to determine the solution to each system. So for letter A, remember solutions are going to be where our lines cross, where they meet. And it looks like we have a point here at 0, 6, so that would be one of our solutions. And it looks like we also have a point at 4, 10. 4, 10. So this has two solutions. For the letter B, it looks like we only have one point where they meet, and it looks like it is at 0, 1. 0, 1. So for this one, we have one solution at 0, 1. And then finally, letter C, it doesn't look like our lines cross at all. And if you guys remember from when we did linear equations, if the lines do not touch at all, it is no solution. So we have a case where we have two solutions, one solution and no solution. And since we have a straight line crossing through a parabola, the most points, the maximum number of points in which they can cross is going to be 2 times. Next, we are going to solve using substitution. So it says, what is the solution to the system of equations? Y equals negative x squared minus x plus 6. Y equals x plus 3. So if we're using substitution, that means that we're taking one of our equations, so we're isolating a variable, and then plugging it into the other equation. So for this one, we have y equals negative x squared minus x plus 6, so the y is already isolated. And in the second equation, we have y equals x plus 3. So again, the y is also already isolated. So we can actually go ahead and take the x plus 3, and we're going to plug that in for y in the second equation. So x plus 3 equals negative x squared minus x plus 6. So we want to try and get everything on one side. So I'm going to go ahead and start by subtracting the x. So I end up with 3 equals negative x squared minus 2x plus 6. And then I'm going to subtract the 3 to move that over as well. So I end up with 0 equals negative x squared minus 2x plus 3. So now I have an equation, a quadratic equation set equal to 0. And there are multiple ways that we can solve this. You can use completing the square. You could use graphing on Desmos. You could use the quadratic formula, any of the ways that we have talked about to solve the equation. We could try factoring, all that kind of stuff. So you just choose a way that you would like to solve it and then solve it using that way. And the easiest way for me is to use the quadratic formula. So I am going to find a, b, and c. So a is negative 1, b is negative 2, c is 3, and I am going to solve using the quadratic formula. So I'm plugging it into x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to go ahead and plug my numbers in and simplify. So my answers are x is equal to negative 3 and x is equal to 1. And make sure you try the you-try problem. So for problems 1 through 3, you are substituting and solving as we did in the last problem. And problems 4 and 5, you're just stating what the solution is to each system, each graph.